In question 6a, we have two 400 ohm resistors in parallel that are then in series with one 25 ohm resistor, and we need to calculate the total resistance. Well, for the resistors in parallel, we can use this formula, and both resistor 1 and resistor 2 are 400 ohms, so we can write this, which comes out at 2 over 400 ohms, not forgetting to invert. Resistance total equals 200 ohms. This is for the two resistors in parallel. But they are also in series with the 25 ohm resistor, giving a total resistance of 225 ohms. In B part 1, there is a potential difference applied across the resistors, and the power dissipated in each of the 400 ohm resistors is 1 watt. We need to calculate the potential difference across these resistors. Well, for this we can use power is equal to V squared over R, so V is equal to root PR. Putting in the values, a power of 1 watt and a resistor at 400 ohms gives a potential difference of 20 volts. In part 2, we need to calculate the current through the 25 ohm resistor. Well, first we can find the current through each 400 ohm resistor using current is equal to potential difference over resistance. Putting in the values gives a current of 0.05 amps through each 400 ohm resistor. Therefore, the current through the 25 ohm resistor is all that passes through the 400 ohm resistors, which is 2 times 0.05 amps, coming to 0.1 amp. For part 3, we need to find the potential difference across the terminals A and B. Well, first the potential difference across the 25 ohm resistor using V equals IR with 0.1 of an amp and 25 ohms gives us 2.5 volts. So the total potential difference is the 20 volts we found previously across the 400 ohm resistors plus the 2.5 volts across the 25 ohm resistor, giving a total of 22.5 volts.